welcome. So this one is in your notes. And so let's go through this one. So we're given the graph of h of x pictured at right. Find the equation of the tangent line to the graph of p of x equals the square root of h of x when x equals -4. All right, so I have the steps listed there. You should write those down. All right, then some reminders of the things that we're going to need to find our information. All right, so step one, we got to find the derivative using the chain rule. All right, so it doesn't matter that we don't even need the equation for this graph because we have the graph. We can find the values there, and this is an easy graph to figure out some of the derivatives for on sections of the graph. All right, so let's find our derivative first. So this is step one. All right, so we have a chain rule here. So step one, find derivative. So we have p of x equals the square root of h of x. We should rewrite that. H of x to the 1/2 power. Right? And so now p prime of x is going to be, we're going to take the derivative, so it's going to be 1/2. Right? We're using the power rule. 1/2 blop. The blop is hx. And then the exponent decreases by 1. And then we need to multiply that by the derivative of h of x. All right, so let's simplify that a little bit. So p prime of x equals, so we have 1 over 2 times the square root of h of x. And then times, we can put this in the numerator, times the derivative of h of x. That's a little messy, isn't it? Let me write that one more time. So d dx h of x, the derivative of h of x over 2 square roots of h of x. All right? Now how are we going to find h of x? Well, we can use the graph, right? So we found the derivative using the chain rule. Use the graph to evaluate the derivative, right? Because all we need to know is, and this is specifically at x equals -4. So, oh, isn't that a lovely underline? So I'm going to write step 2 in a different color. So step 2, p prime of x, we're going to evaluate, right? So we need the derivative of h of 4. And remember that all that is, it's the slope of the tangent line when x equals 4, right? So when we're finding the, so I put take the derivative. Maybe we should take the derivative. Sorry. I kept writing take the derivative. Let's just take the derivative. All right, so in the p prime of x is h prime of 4 divided by 2 square roots of h of 4. All right, so p prime, that's going to give us the slope. All right, to find the slope, we're going to need to find the value of the function. All right, so here I'm reading from here. H prime of x, that's the slope, and h of x is the y value. All right, so we just need to find the slope when x is negative 4, and then find the value of the function. Well, this is pretty easy to find the slope because it's linear. So this slope is -1/2. So that means that h prime of -4 is -1/2. So where we see h prime of -4, we're going to put in -1/2. Well, and technically I probably should have put a -4 there too. So we have -1/2 divided by 2 square roots. So now let's find the value of h of -4. All right, so h of -4, that is right there. It is negative 4, 4. Actually, I wrote it down right here. Negative 4, 4. All right, so when we plug negative 4 in, 4 comes out. So now we're going to simplify this. I guess I'll just go across. So this would be negative 1/2 divided by 2 times 2. Right? That's the square root of 4. So this would be negative 1/2. If we're dividing by 4, that's multiplying by 1/4, right? So it's negative 1/2 divided by 4 is negative 1/2 times 1/4. So that would be negative 1/8. So there we have the slope. All right, and now we've got the point. All right, so step 3, write the equation of the tangent line. That's the easiest part of all. So it's going to be y minus 4 equals negative 1/8 x plus 4. And we can move the 4 over. Y equals negative 1. Oops, that's supposed to be an 8 there. Negative 1/8 x plus 4 and plus 4. If you want, you can rewrite that into slope-intercept form, or you can leave it like that. This is fine. So if you make it in slope-intercept form, that would be negative 1/2 plus 4, so it would be y equals negative 1/8 x plus 7/2. Yeah, but this is fine. All right, and let me know if you have any questions. All right, so here we're using our derivative in context. We're using a graph, and we're being able to interpret that derivative based on the graph of the function. So now I'm going to use a table. All right, so let f of x and g of x be differentiable functions such that the following are true. So we have values of x, we have values of f of x, g of x, f prime of x, and g prime of x. Is the graph of h of x equals f of g of x increasing, decreasing, or at a relative max or minimum when x equals 3? Give a reason for your answer. Well, we know that we're going to have to find the derivative first, and then we're going to have to see, is it positive or is it negative? All right, that'll tell us increasing or decreasing. Let's write that in actually. So here, h prime of x would have to be positive. For decreasing, can I write here? No. H prime of x would have to be negative. And for relative maximum minimum, I can't squeeze it in there. I can squeeze it in, but you can't read it. Right? H prime of x would have to be 0. And then we would evaluate values on either side. Man, can't even seem to write an equals and a 0. That doesn't look like it went through a trash compactor. Well, now it's too big. There we go. Squeeze it right in there. All right, so let's find the derivative. All right, so we want to find h prime of x. All right, and we know h prime of x is going to be the derivative of the outside. So f prime, and remember the inside doesn't change. Right? The block stays the same. So f prime of g of x times g prime of x. I highly encourage you to write this equation down and then plug your values in. Because students make mistakes with this all the time. Not because it's very difficult, but because they're skipping steps and they're being careless. All right? Don't be careless. Be cautious, and then you won't make a mistake. So we want it when x equals 3. So we have h prime of 3 equals f prime of g of, where's my parentheses, g of 3 times g prime of 3. All right, so we're going to plug in g of 3 into, we're going to find g of 3 first. All right, and then once we find g of 3, then we can find whatever f prime of that is. So I think these are kind of fun ones. So g of 3 is, so there's 3, g of 3 is 4. So we want f prime of 4. Right? So notice we're getting that value from the inside function. And then I will look up this in a second, g prime of 3. So h prime of 3 equals, so f prime of 4 is going to be 8. And g prime of 3 is 6. So that is equal to 48. All right, so I'm going to erase all these random lines. So that means h of x is increasing at x equals 3 because h prime of x is greater than 0 at this value. Right, we found the derivative, right, and then we evaluated, and well, it's positive. So if it's positive, the function is increasing. All right, let's try the next one. All right, so p of x is equal to g of 2 of x. What is the value of p prime of 1? All right, so we've got 2x. We've got a function inside another function. This will be the chain rule. Right? So both of these were the chain rule. Maybe I should write that up there. Right? Anytime you've got composite functions, it's going to be the chain rule. So p prime of x is going to be equal to g prime of blop times the derivative of blop. And this time the blop is a 2x. Okay. So now let's plug in our 1. So p prime of 1 equals g prime of 2 times 1 times the derivative of, excuse me, wait. I'm evaluating whether I should keep that. I think it's just supposed to be I don't think we're supposed to plug into, you know what, yeah. Oops. We got to take the derivative of 2x first, right? We don't have a chart up here. Like, so over here, I can just write g prime of 3 because then we're replacing it with the value, which was 6. Right? Here, I need to take the derivative before I do any plugging in. Right? You know, plug in and then take the derivative. So p prime of x equals, so g prime of 2x, and we're going to plug in a 1 there. And the derivative of 2x is 2. I started to write that down as wait. It's not just supposed to be a number. It's a function. Oh, wait, I forgot to take the derivative. All right, so we take the derivative, then we plug in. So now we can find p prime of 1, which is g prime of 2 times 1 times 2. We can move that 2. Actually, you know, that 2, that would look nicer in front. So we have 2 times g prime of 2x. All right, so, oops, whoops. But now I am supposed to plug in. All right, so once we take the derivative, then we can plug into x, right? 2x isn't going to change, right, because the blop doesn't change, right? But then we take the derivative of the blop. So I had to make sure I took the derivative before we plugged in the 1. But now we can simplify that. 2 times g prime of 2. All right, well, g prime of 2 is right here, -1. So we have p prime of 1 equals 2 times -1, which is -2. All right? So just be careful when you're taking the derivatives. Make sure you finish taking the derivative before you plug in. All right? And we're done with that one. Let me know if you have any questions on these. Okay? So on that second one, the outside function was g. The inside function was 2x. On the first one, the outside function was f of x. The inside function was g of x. I think I'd like to do this one. All right, so let f of x and g of x be different. And yeah, by the way, these are all in the notes. Be differentiable functions such that the following are true. So if q of x equals the square root of f of x plus g of x, what is the value of q prime of 4? What does this value say about the graph of q of x when x equals 4? Give a reason for your answer. All right, so let's find this. All right, so here we do have a composite function, so this will be the chain rule. All right, so Q, and always write your derivative, right? Always write your rule first. Don't try to start plugging things in, because that's when you're going to make mistakes. So Q prime of x is, actually, let me rewrite the function with a rational exponent. So Q of x equals f of x plus g of x to the 1/2 power. All right? So now Q prime of x equals 1/2 and then the blop. So f of x plus g of x. Reduce the exponent by 1. So that would be to the negative 1/2 power. And then we need to take the derivative of f of x plus g of x. Now that's just a sum. And the derivative of a sum is just the sum of the derivatives. So Q prime of x equals 1/2, and now actually we want to plug in now. We found the derivative. Now notice I couldn't do anything more with the derivative of f of x and g of x until I plug in a value, right? Because we're using a table, right? It's not like we have a function. We have a function, but its values are in the table. So Q prime of 4 is 1/2 times f of 4 plus g of 4, and we're taking the, I should probably simplify that out, but maybe I'll do it on the next step. And then we're taking the derivative of f of x plus g of x, so that's going to be, we're just going to multiply by f prime of 4 plus g prime of 4. Part of me thinks I should have made this look prettier first, but I think it's okay. I wonder if I did that one last time I did this problem. All right, so we have, and well, I'll just keep leaving it like this. We'll simplify at the end, I suppose. So we have, actually, you know what, let's just simplify the negative exponent. May as well let our terms be in the right spot. All right, so 1 over 2 times the square root. All right, we'll plug in the values. F of 4 is 1, and g of 4 is 7. Well, it's not a pretty number. Yep. And then we're going to multiply that by f prime of 4, which is 8, plus g prime of 4, which is negative 2. Just making sure. Yeah, I guess so. All right, so q prime of 4 is going to be 1. Let's simplify. So in the numerator, we have 1 times 6. So that's 6 divided by 2 square roots of 8. We could simplify that. So we should cancel out the 6 and the 2. So 3 and the square root of 8 is 2 square roots of 2. So there's our answer. When x equals 4, because q prime of 4 is greater than 0. Right? So that number is greater than 0, so it is increasing. Right? Oh, I suppose we'll do this one because it's a really easy problem. It looks like it might be hard, but it's really not. So find the following limit, and this one's in the notes as well. Explain the reasoning. Boy, this must have been a bad day for the board. Some days the glitches is worse than others. That's a little better. Explain the reasoning you used to arrive at your answer. The limit as h approaches 0, I think part of this got erased, of cosine x plus h, cosine 3 times x plus h minus cosine 3 of x all over h. Now you should recognize that this is the limit definition of the derivative. It is okay for you to evaluate using something other than the limit definition. So So unless I say evaluate using the limit definition, and I wouldn't say that for a problem like this, it's a little bit trickier, you can use derivative rules to evaluate. Unless stated otherwise. All right, so unless I tell you you must use the limit definition, you are free to rewrite this and find the derivative another way. And then in this case, it would be a good idea. This is mainly seeing, do you know, can you recognize that when you see the limit of a function where we're adding an amount that's approaching 0, do you recognize that to be the derivative? All right, so that's the big idea. The big idea here is, do you recognize the derivative? And then do you know a proper rule besides using the definition of the derivative? And I think you have a hard time with this one because this one would require a bunch of different rules. We have a cosine of a sum, right? So we have to use the sum and difference rules for cosine. And it can be done, but it's a little messy. I do it like once to show you. I think I did it once to show you the derivatives for sine and cosine, and then I didn't do it again. So this is the same as saying, so we'll just call it f of x, or we'll call it y. All right, so y equals cosine 3 of x. Right? This will be a little chain, right? So the derivative dy dx is equal to the derivative of the cosine blob times the derivative of the blob times the derivative of 3x. So the derivative of cosine blob is going to be negative sine blob, and of course the blob is 3x, and then the derivative of 3x is 3. We should make that look a little nicer. So dy dx equals negative 3 sine 3x. And there we go. I am fine for you to do that. I am not expecting you to use the limit definition on a problem like this. So I think that's where I'm going to end this video. Thanks for watching. Bye for now.